With the rise of generative AI, the scale of global data centers is expanding. Better chip performance increases power use, making heat a major challenge for data centers. But AI chip leader Nvidia is leading vendors to develop next-gen liquid cooling tech. What exactly is liquid cooling? Compared to traditional air cooling, what are its advantages? Will liquid cooling become mainstream? Data centers mainly use air cooling now. It uses heat pipes to first conduct heat away, then fans and air convection dissipate the heat. Liquid cooling, however, uses liquid instead of gas. It includes direct-to-chip and immersion types. Direct-to-chip cooling uses a cold plate to transfer a server's heat to the coolant. The coolant flows out of the server via pipes, then dissipates heat via a heat exchanger. The cooled liquid returns to absorb more heat, beginning the next cooling cycle. The process is managed by a cooling unit, forming a circulation system. Immersion cooling directly soaks servers. Heat dissipates directly via liquid convection. Due to technical issues with long-term soaking and facilities must be redesigned, immersion cooling is still in small trials. The liquid cooling promoted by the industry is mainly direct-to-chip liquid cooling. Compared to air cooling, liquid cooling's main advantage is capacity. Air cooling's max capacity is 500 watts, while liquid cooling's is over 1,000 watts. The Nvidia H100 chip consumes 700 watts, which can still barely be cooled by air. But Nvidia's new Blackwell chip's power use has reached 1,000 or even 1,400 watts, far exceeding the limits of air cooling. Liquid cooling becomes the best choice. Liquid cooling is also more efficient than air, as liquid's thermal conductivity is superior. It can quickly absorb and transfer heat. The improvement in cooling efficiency can further reduce power consumption. According to the Ministry of Economic Affairs, Taiwan's total power use in 2023 was about 270 terawatt-hours. By contrast, the IEA estimates global data center power consumption in 2022 was much higher than Taiwan's annual. A data center's vast power usage, up to 40%, comes from air cooling. If more efficient liquid cooling is used, that number can be reduced to about 10%. Though liquid cooling requires cooling towers and the initial investment is higher, with better long-term efficiency, it can reduce electricity consumption, so the cost is actually lower than air cooling. Liquid cooling also doesn't need AC units, taking up less space in server racks. Plus, with no fans, it generates less noise, better complying with workplace safety rules. These benefits are shifting data center cooling to gradually shift from air to liquid cooling. With high-power Blackwell chips shipping, demand for liquid cooling in data centers grows. According to the latest survey by TrendForce, liquid cooling's market share is estimated to grow from about 10% this year to over 20% by 2025. This trend spurs vendors to enter the market, like cold plate makers Aorus and Cooler Master, and CDU makers like Vertiv and Delta. But for liquid cooling to become widespread, there are still several challenges to overcome. First, the risk of leaks must be reduced. During liquid cooling operations, if even one drop of water falls on a server, it could cause the machine to be written off. Nvidia's GB200 reportedly had leaky parts, causing rack leakage. Liquid cooling's cost is also relatively high. The GB200 liquid cooling system costs over $80,000, 15 to 20 times that of an air cooling system. This is also a problem that needs to be solved. Its environmental impact is also emerging. Musk's xAI built a supercomputer in Tennessee, which uses liquid cooling for heat dissipation. It draws about 110,000 liters of water daily, drawing protests from residents and activists who believe it will worsen local drought issues. The latest data also shows that due to increased data center usage, Microsoft's water use rose by 34% in 2022, Google's by 22%, and Meta's by 3%. While liquid cooling reduces power consumption, it accelerates the depletion of water resources. To solve this problem, these companies are actively restoring wetlands, hoping that by 2030, the water they add will exceed their data centers' water usage. While liquid cooling's development has concerns, with rising chip power consumption, data centers' need for cooling will only rise. But air cooling has a hard thermal limit. If leak, cost, and eco issues are solved, the future of liquid cooling is still promising.